Today's daily LeetCode problem of the day is rotating the box number 1861. So, for this problem, we're given an m by n matrix of characters called box, representing a side view of a box where each cell of the box is one of the following: either a stone, which is our hashtag symbol, a stationary object, which is an asterisk, and an empty box, which is just a period. So the box is rotated 90 degrees clockwise, causing some of the stones to fall due to gravity. Each stone falls down until it lands on an obstacle, another stone, or the bottom of the box. Gravity does not affect the obstacle's positions, and the inertia from the box's rotation does not affect the stone's horizontal positions. It is guaranteed that each stone in box rests on an obstacle, another stone, or the bottom of the box. So, for this problem, we could say that we have an m by n grid. Let's go ahead and give ourselves a little tic-tac-toe chart. Maybe we'll add one more length to it. So we have a grid like this. All of these dots are going to be empty spaces, and then we have hashtags, which are our stones. So if we have a hashtag there, we have to have two things, or at least one thing below it to hold it up. So let's say these are our stones. We can have an asterisk here, and let's say no asterisks here. So we're going to flip this box and give it a little border 90 degrees. So we're going to take this side and we're going to point it that way. So we're going to have a box that ends up looking like this. So we're going to have two, right? And then we're going to go 1, 2, 3. Give it its little border. Our stones are going to initially start here. The initial position of our stones is here. Actually, I could change it to a different color. So let's say the pink is our stones, right? Pink is our stones. So these are our stones. And then we have asterisks here and here. So if we rotate it 90 degrees, the asterisk positions are going to be here and here. Everything else is empty space. So for this to work, our stones are going to have to fall, and they're going to fall down to as far as they could go. So this stone is going to fall all the way to this bottom square. This stone is going to fall all the way down to this square right here because it's going to land on an asterisk or an object. This stone will not move because there's an asterisk or an object right there. So that's where it's going to end up staying. So, using that understanding of how this problem is going to work, let's go ahead and review how we're going to address this problem. So, our plan. We're going to first rotate our grid 90 degrees clockwise by transposing the grid and reversing the rows. This is just a simple way for us to, like, code-wise flip the grid onto its side so that we can analyze how the stones will fall. We will then simulate our gravity. So after rotating, we will simulate the gravity by letting the stones fall to the lowest possible position in their respective columns. So we're going to have to traverse these columns in some way to find either an obstacle or the bottom of the grid or another stone. Finally, we're going to return our transformed grid. So let's go ahead and jump into the code and see how this is going to look. First thing we're going to do is identify our integers m, which is box.length, and n, which is going to be box of 0.length. The reason we're doing that is just so we can craft the rotated grid using the same variables that crafted our original grid. So we're going to have a char array called result, which is going to be our new grid. So new char of n by m. So our original grid is m by n. Our new grid result is going to be n by m. So we're flipping it on its side. Now we're going to transpose the input grid into our results. So it's going to be a nested loop for each integer I. Start at the beginning. As long as I is less than n, I can increment. And our nested loop int j is equal to 0 as long as j is less than m, j can increment. So result of I of j is going to be equal to box of j of I. So this is how we are kind of mirroring the rows and columns. So let's say we have a grid like this. We're going to make it not even, right? So this is 0, 0, this is 0, 1, this is 0, 2, this is 0, 3, so on and so forth, right? So if we're looking at result of I of j, let's say I is 1, j is 2. So we're going to go 0, 1, and then 2, so 0, 1, 2, right? So what we're going to do here is we're looking at this position in our result grid. But if we're looking at our original grid is going to look something like this. It's going to have three columns, 4 rows. So box of 2 of 1, it's going to be 0, 1, 2 over 0, 1. So we're looking here. And as you can see, it's the same spot if we rotated this 90 degrees. Right? So that is how we are kind of mirroring the box so we can transfer all the data into our new box. So we're going to reverse each row to transpose the grid, and it'll be equal to a 90-degree rotation. So for each, this is going to be another nested loop. I is equal to 0 as long as I is less than n, I plus plus. The reason we have to do this is if we are in a position on the outside of the grid, let's say if we're looking at this position, so this is 0, 1, 2 for us on top. If we have 0, 1, 2 for us here, it's going to be on the opposite side. So we're going to mirror it to put it on the right side. So it's going to be a nested loop for integer j is equal to 0 as long as j is less than our m value, but divided by 2 because we're going to kind of flip it in half. J can increment. So char temp is going to be equal to result of I of j, so that's our temporary variable. Result of I of j is going to be equal to result of I of m minus 1 minus j. So this is going to be the opposite side of what we're currently looking at. So result of I of m minus 1 minus j is going to be equal to temp. Simple variable flip in this nested loop for each column. Now we're going to apply the gravity to our stones to let them fall into all the empty cells below them. Another nested loop. So for each integer j is equal to 0, as long as j is less than m, j can increment. So we're going to have an integer, and we're going to call it our lowest, and that's going to be equal to n minus 1. Why are we using n minus 1 here? So we're doing this because we're going to start at our bottom row, and then we're going to kind of traverse upwards, and we're going to keep track of what the lowest row is, and that lowest row is going to theoretically be the one that is right above a rock or a object or whatever else. So we'll find that by doing another for loop. We're going to set our integer i's equal to n minus 1, and then as long as our I is greater than or equal to 0, we are going to traverse our I negatively, but that's going to traverse it. Think about it like this. So 0, 0 is at the top of our grid. So let's say our I is starting here. We're going to traverse our I upwards in the grid, if that makes sense. So in this for loop, if we find a stone, we're going to let our rock fall to the lowest empty cell. So if our result of I of j is equal to a pound, AO, not a pound, literally, but a pound, then our result of I of j is going to be equal to a period and then we're going to set our result of lowest of j equal to a pound. And then we can increment our lowest up one cell. If we find an obstacle, oopsies, if we find an obstacle, we're going to reset our lowest with empty cell to the row directly above it. So if result of I of j is equal to asterisk, sorry, let's make sure that we double equal this. If it's equal to an asterisk, our lowest will be equal to the cell directly above it, or I minus 1. So this is simply going to set our rock into any of the empty cell positions. And by doing this, we can then return our result grid. So if we run this, that passes our test cases, and if we submit it, that passes all of our solutions. So let's break down our code again, just so we can understand what's going on. We are first going to rotate our box, creating its transpose. So here we are creating a 90-degree version of our original box. Then, once we have everything kind of set up how it would be if we just rotated it 90 degrees and moved everything over naturally, now using our whatever grid we have left, we are going to mirror it. So whatever is here is going to go over here. Whatever is here is going to go over here. Because as we have it now, it's not necessarily the same, because we're not rotating it the same per se. It ends up being kind of mirrored to what we want. So if we have something like this and we rotate it, it's going to end up like this. So we want to mirror it to the other side, so it's more of a 90-degree flip. So after we do that, we then can simulate our gravity. We start from the bottom row and progress upwards, tracking the lowest row with an empty cell, which is where our next stone will land. We'll move our stones down to the lowest available empty cell, and we'll reset our lowest whenever we encounter an obstacle. So that's it. Thank you. Follow for more daily LeetCode solutions. If you want to learn to code, check out the link in my bio today.